Now in this 2-hour session, we are going to cover an important topic related to IoT, that is called cloud computing. So most of you have the knowledge about cloud computing and how it is working and what are the different services and essential model it has. So we are going to see from the very basics, and we'll try to understand the need of the cloud in IoT, and we'll try to discuss about it, that why it is important and why not it is important. So about the importance we'll see on this particular session. Let's see what do you mean by cloud computing. So we all know uh, as a computer user or as a internet user, we all know that the very basics of the cloud computing is there is some computing platform or some computing infrastructure which are remotely placed somewhere. That is the abstraction. We don't know the exact location of that particular computation resources which has, but we can use those resources, and we can use those computing resources through the internet. So cloud computing is the platform which provides us the services of these virtualization. Means we can use either computing power of the remote system, or we can use the storage area of the remote system, or we can use some other sorts of services related to the cloud service provider. So as we all know that in today's scenario, when you use a smartphone, so any company that you are having a smartphone is, let's say I have a smartphone of Apple. So Apple has a cloud, a separate cloud, Apple Cloud, right? In which I can store some sort of my photos, some sort of videos, some sort of documents that I don't want to lose. So those photos or those important videos or those documents I'll put into the Apple Cloud. So let's say at some point of time I lost my mobile phone. So when I purchase another mobile phone, I know my ID, I can just download those photos or those video which are there in the in the Apple Cloud. So that is an example of mobile phone. So you all use the mobile phone, right? And you all somewhere you will get some sort of free, let's say 10 GB, 15 GB of memory by these companies, and you can use it for storing your valuable data. Uh, that one example that we are using very frequently nowadays. Second thing, if we'll talk about these cloud services, are, let's say, the email services that we are using. So all the email services are nothing but the cloud services provided by these cloud service providers, and we are using those services. Somehow we can also do some sort of processing also. Let's say if we talk about Google has a platform Kaggle, right? In the Kaggle, there is a machine learning platform they have given. So you just upload your data, or you can use the data which is already there in the Kaggle, and you will use the GPU of the Google. So the GPU and the processing power they will provide you. On that, you just write your algorithm, machine learning algorithm, and you can do any sort of computing. So in the data sciences, nowadays it is very popular. So these are all different examples of cloud computing. So first, in this particular lecture, we first go through the cloud computing basics, and slowly we'll move on to the will relate it to the IoT, and we try to understand that what is the importance of cloud computing in IoT. So why cloud computing? This is the biggest question that anybody will ask you, that if we'll go and tell the organization that I am this cloud service provider, and I want to provide you service. So my client will definitely ask me that what you will provide me, what I don't have that you want to provide me, right? I have the computing power, I have the networking, I have the people who will manage those things for me, and I can purchase a large amount of computing capability. I can own high computing servers. So why you are here, or what type of services that you can provide me? So to answer to that question, let's go to that particular slide, and we'll see that if we have the computing resource on the premises, and if we are using the computing resources provided by the cloud service provider, which are there somewhere remotely, so what are the differences between these two? And we'll try to understand that. Let's say I am the new company, I am the startup, and I have, let's say, 25 to 30 employee, and right now I want to open a office in which I want to have a IT infrastructure, right? So what I have to do? First of all, I have to own the premises. Second thing, I have to own the computing resources. I have to purchase it, right? I have to purchase the hardwares. I have to purchase the software which will use in the hardware, like operating system, like other virtualization software, many other license software that I'll use in my firm or in my startup. All those things I have to purchase. So the first point is higher pay, less scalability. So what we have to do is, in the very beginning, we have to pay a big amount of money for purchasing a computing resources. First thing. If we'll go in the cloud, so what we have to do here, in the cloud, we doesn't have to own anything. If I want to use the cloud services by any cloud service provider, so what I'll do, I don't have to purchase anything. Instead, what I'll do is, I'll pay for what I'll use. So whatever I'll use, based on that, I'll pay to the cloud service provider. Here it is less scalable. Why it is less scalable? Let's say I have a high performance computing with, let's say, a 64 core, and I have, let's say, 128 GB of RAM. I have, let's say, 100 TB of hard drive, and that particular high performance computing, and I have many, let's say, 16 or 32 number of GPUs, which are also available on that particular high performance computing system, that I want to use for my firm. Means all 30 people will use it. But let's say at some point of time, my firm size has been increased to 50, and slowly I find it out that this computing power is not enough for existing strength of my company. So what I'll do is, I have to purchase more hardware, or I have to upgrade the hardware. I have to scale up the hardware, right? So that thing I have to do for if I am using the hardware in my premises. But here, on the other hand, in the cloud service, is it will use the cloud service, and based on the cloud services that I'll use, I'll just pay it. So if, let's say, 30 people are there right now, and the 1 month or 2 month of time, it has been increased to 50. So definitely my requirement will be scale up, and cloud computing providers will be scale up the resources that I'm using, the firm is using, and based on that I'll pay. So I don't have to purchase a new hardware resources, right? No, if somebody will say that, then what is the usefulness of that? If I'm not the owner of that hardware that I'm using it, and I am the owner of the hardware that I'm using it, so that is better, right? But the thing is that initially the cost is very high. Let's say if I am the new firm and I want to have to set up all those things, the initial cost of high performance computing is more than 1 crores. So I have to invest more than 1 crore initially for my server setup. Instead, if I'll use the cloud computing platform, so I have to pay it in a rental basis, monthly basis, where the cost will be very less. It will be more cost effective options. Second thing, if I have spent, let's say, 1 crores of high performance computing, and at 2 months of time I need to purchase some more 1 crore, so I have to invest another 2 crores for the hardware again. And you know that the hardware, the purchasing of the hardware is okay, but what else we have to do? Allot a huge space for server. So we need the server. We need a server room itself. Let's say I am the new firm, and let's say I have, let's say 10 rooms available for in the building, and I have opened the office in the 10 rooms, and 1 room or 2 room I have dedicated to the servers. So and if I'm using the cloud computing, so I don't have to waste that space to put the servers, right? I'll utilize those spaces for my office use, right? That is the main thing. So here no server space is required. It is obvious. Now, what are the other thing that I have to do when I have purchased the hardware? I have to appoint a team for hardware and software maintenance. So I have to uh, create the employment for those hardware maintenance guy, so server guy, right? Data science, data center guy. So we have to appoint those guy. It is also a liability to me, means it is a extra that I am paying, right? They are not doing the valuable thing, they are just maintaining those hardwares and those servers, and to maintain those softwares also, so I have to purchase the software also and to maintaining that. But here, when I use the cloud computing, I don't have to appoint any expert. That is for the hardware or the software maintenance. So here the cost effectiveness is there. Now, poor data security. Now here in the premises or in the server, we have to maintain a very high level of security when I want to provide the security, right? But here in the cloud computing, security will be uh, the primary focus of cloud service provider. So they will, it is a paramount requirement for them to provide us the secure way of um, storing those data, secure way of retrieving the data. Means they are using a good way of authentication. They will use good way of confidential confidentiality of the data, encryption decryption mechanism. They will use the highly and latest security way of doing that. They will use a latest firewall for that. So here the security will be better. About the security, we'll discuss more in the later period of time, and this particular point we'll discuss in deep. Last chance of data. Now here the data recovery chances are very less because my data is there in the server, and if server crashed, or like Fanny phenomena happen in Odisha, the same way if something happened, disaster happened to the to that particular state or to that particular location, so I'll be out of the power for days, or because of the thundering or lighting, there may be the damage of my hardwares. To retrieve the data, it will be very difficult. But here in the cloud computing platform, if we'll take, they will actually do the multiple copies, or they will make the redundant data. So here the recovery of those data is very much easier in the disasters. as well as we doesn't have to worry about the power and all those things, right? Still, my firm will be open 24/7, which are the phenomena that many companies are using, right? So that is what the positive thing in cloud computing, that we can use it. Next, lack of flexibility. Now, flexibility is not there. Flexibility in the sense that if you want to increase, scale up or scale in or scale out the resources, it is not flexible in that particular point of time. Means we cannot scale down, we cannot sell our resources, our hardwares, or we cannot scale up. We have to purchase a new high performance computing, or we have to add some more racks into the servers. So the flexibility is less here. Another thing that is there is, let's say we have 30-40 employees which are there in my firm, and those are having different accounts to use it. And let's say 3-4 people uh, have left out my company, still they have the username and password with them. They can do some mischief, or as well as if we want to add some more, and so we have to add some more employees manually. But here what we'll have is, we just go through the cloud service providers, and we can just, with one click, we can increase the number of users, we can generate the credential for that particular employees. So the flexibility is less here in the on premises if we'll create infrastructure, or if we want to use the infrastructure which is already created by the big companies. So here the flexibility is high. No automatic update. So here we have to update the software, we have to update the hardware. Both software and hardware updation is not automatic, we have to do manually. But here automatic software update is possible. So if we are using, let's say, the office, latest office, let's say 365, and some other version has come of the office, and you want to use it, then you have to purchase it if you are using on premises. But here in the case of cloud computing, what you can do is, you can use the latest one provided by the cloud service provider very easily. Here the collaboration is less, but here collaborative work is very much possible. Widespread locations, if your teams are there, they can collaborate it very easily, and with more convenient way, because everything is in the cloud. Data cannot be accessed remotely. Here the data can be accessed anywhere over the internet. That particular point is, you can say that nowadays that particular point is of no means, because we can access the data remotely also. If we create a server and we give the credential to the employees, so we can use it. So that particular points is outdated in today's scenario. But still, there's a good point here, that we can use those data, we can access those data anywhere with any type of devices, or any type of heterogeneous devices that we want. Takes larger implementation time here, and here rapid implementation is very much possible. It means that if you want to make your infrastructure, you have to wait for, let's say, to purchasing the hardware, to installing the software on it, to configure the firewall for it, to configure the access control policies, and to manage all the building, put the AC, and you have to make the connection, everything. Means it will take a longer period of time. But here the infrastructure is already there. You just have to use it with their interface. So they will give you a GUI and you can use it. So these are some points that differentiate between on-premises infrastructure and the cloud infrastructure. So which one is better? So why cloud? So the answer is the usage of the cloud is very easy, flexible. You can scale up, you can scale down, and it is very, you can say the function is rental type of function. So what they will do is, they will rent, give you, means they will rent the resources of their hardwares and the softwares, and you just have to use it, and whatever you'll use it, you have to pay it. So let's see what is a cloud computing. So in the layman language, we can say that the cloud computing is the delivery of on-demand computing service over the internet on a pay-as-you-go basis. Now here the cloud computing is the delivery of on-demand computing. So here we are talking about on-demand computing services. Means that these services are based on the requirement of the customer. So if customer require just now, this will be available for him to use over the internet. Definitely we have to use the internet to access those remote computing services. As well as it is a pay as you go basis. Means if you want to use it, then you'll pay, and then some services are free, some services are rental. So those services which you want to use, you can use it. Rather than managing file on a local storage device, cloud computing make it possible to save them over the internet. Yeah, that is true. Like if you want to store your valuable data, so what are the means that you will use till now? Either you will use pen drive or the disk or the hard drive to store your valuable data. But nowadays, what we do is we'll use the platform like Google Drive, Dropbox, in which we'll just store our valuable files. And here, the corruption of these data is very much possible. You can what these can be forgotten. Means this can be damaged, or you can forgot your pen drive anywhere, right? So even if I'll consider myself, I have purchased, I think 20-30 pen drive till now, but right now I don't have any pen drive available with me. So you can forget all those things, but here if you have the valuable data, definitely it will cost you. But instead, if you use cloud services and put your data in the cloud, it will be there for a longer period of time, definitely. As well as you can download all those data whenever you want. Okay, so this is some differences between the cloud and whatever you are using till now. Let's go to the formal definition of cloud. So the cloud computing definition, which is given by NIST, National Institute of Standard and Technology. So NIST has given the definition of the cloud computing. Let's see this particular definition. So the cloud computing is a model of enabling ubiquitous, convenient, on-demand network access to a shared pool of configured computing resources. That is network, servers, storage, applications, services that can be rapidly provisioned and released with minimal management effort or service providers' intervention. Now, to understand this particular sentence, let's go into deeper to that. Now, what this standard definition says that the cloud computing is a model for enabling ubiquitous, convenient, on-demand network. So it is talking about the computing services which are available to you very conveniently on demand basis, and that can be accessed through the network. And these are nothing but shared pool of configured computing resources. Now you can access those things with heterogeneous devices, as well as with thick and thin client-side softwares. You can use those client-side software or the applications, and you can use those services through the network. What are the services? These services are shared pool of configured computing resources. These services are nothing but the computing resources which are based on the model of shared pooling. Shared pooling means, so here, what is the meaning of shared pooling? Shared pooling is, let's say if there is a cloud service provider, let's take an example of Amazon. Amazon is giving you some sort of cloud services, and these cloud services, they are putting into one infrastructure. Let's say they have made one high performance computing server. Do you think that that particular hardware is dedicated to you or dedicated to one people or one sort of group? Not at all. These particular hardware is actually shared between different users. So all those computing resources are shared, and they use the concept of pooling. So pooling, you know that the concept of carpooling. What is the meaning of carpooling is, let's say I'm going to my office alone. So if I'll take some of my faculty with me, so what will happen is we can share the expenses, right? So that resources, which is a car, can be pooled by two or more faculties. Now, the same thing will happen here. If there is a hardware, let's say if there is the RAM of 8 GB, and there are 8 people, so it is not at all possible that all the 8 people will work at the same time. Sometime what will happen is there will be 7 people, there will be 5 people, there will be 6 people online. So what it will be that 8 GB of RAM will be managed by all those online customers. It will be shared between them. Just way of just the way of processing also. Let's say if I am using just to host my website, over there I don't need a high value, or the requirement of processing power is not high. But if somebody is using some somebody is processing its program of, let's say, data science, and it has to process a huge amount of table or huge amount of data or a huge amount of table, so definitely it is requiring more GPU or more processing power. So that processing power will be given to that person who require more, and will be taken out whenever it is required less. So what I want to tell you is, we are talking about shared pool configurable computing resources. Means those computing resources are in the model of share pooling that can be accessed through the networking and can be accessed by heterogeneous devices, either your mobile phone or your iPad or your laptop or your desktop or any type of workstation that you can use it. So what are those computing resources? Those computing resources are networks, server, storage, applications, and services. These are all computing resources that can be rapidly provisioned and released with minimal management. So that can be rapidly provisioned means it will be allocated to a customer, or it can be allocated to a user with minimum management, and rapidly it can be done. Rapidly means in an instant you will get your virtual machine. Quickly you can get your platform to execute. Quickly you can open your email account or your LinkedIn account or your Facebook account very easily. It is available to you very easily, as well as with minimal management effort. I don't have to put much effort to configure my system to make my virtual machine. And these services are provided without the intervention of the providers. Providers is not going to do any intervention. Instead, they will just manage the background of it, and rest will be done by the cloud computing features that will be, we have already configured the system for that. So that is called cloud computing. In NIST definition, they have listed five essential characteristics of cloud computing. So let's say if somebody want to make the cloud computing infrastructure. Let's say I want to make the cloud computing infrastructure for my institute, right? So what are the essential characteristics that I have to follow, or what are the essential characteristics that should be there in my cloud computing infrastructure? Those are, first is on-demand self-service, broad network access, resource pooling facility, rapid elasticity or expansion, and measured services. So all these five essential characteristics should be there to any cloud computing provider. So if we'll talk about the cloud computing provider like Amazon, Google, Microsoft, IBM, Salesforce, Digital Oceans, all those are different renowned cloud service providers. All those follow these five essential characteristics. Means these characteristics should be there in a cloud computing infrastructure. It is also listed three service models. So three services model is there. So it is not required like every cloud service provider will provide us three services. It can provide one service, it can provide two service, or it can provide all the three services. It is the capacity of the cloud service provider, how much services they want to provide. So based on the services, the models are software as a service, platform as a service, and infrastructure as a service. And there are four deployment models are also there. Means based on which particular model I want to make for my firm or for my usage or for my means company usage. So I can make private cloud, I can make community cloud, I can make public cloud, as well as I can make hybrid cloud. So there are four type of deployment models related to the cloud that together categorize the way of delivering cloud service. Now these are different models, these are different services, and these are different essential characteristics of cloud computing. So in this particular slide, what we have understood? So we have understood one thing that we have understood is what do we mean by cloud computing? So cloud computing is nothing but a shared pool of configured computing resources. These resources can be accessed by any person using any type of devices or any type of thin or thick client-side software that is provided by the cloud service providers. To using that, a user can use the service very easily with minimal effort, and very quickly an individual can get all those services. This we have learned about the cloud computing, and then we have gone through different characteristics, different services, and different deployment model. Now let's talk about the characteristics first related to the cloud computing. So there are different characteristics that we'll see one by one. Now, as I told you, there are five different characteristics related to cloud computing. Now, the first one is on-demand self-service. Any service or any cloud service provider is providing their service on demand. Let's take an example of a virtual machine. Let's say I want to create a virtual machine in the Amazon Web Services, AWS. So for that, what I'll do, I'll go to the Amazon Web Service website. Okay. Then what I'll do, I'll create my account, and third, what I'll do, choose the service, choose what I have to use. Let's say I want to use a, a Unix operating system with, let's say, 2 GB of RAM, and let's say 100 GB of the storage, and I require 4 core, right? This is my configuration. I want to use Linux operating system to be there in my virtual machine, where I'll choose 2 GB of RAM, I'll choose 100 GB of storage, and I'll choose at least 4 core should be allotted to me. 4 CPU core should be allotted to me. Do we require GPU? So let's say if I'll require 2 GPU. So 2 core GPU will be allocated to me. So in that way, I'll make this configuration. I'll just click that particular button and submit. Once I'll submit it, because we choose what are the requirements are, they will make a script. They will convert it into a script, and they will run into a uh, virtualization software on it, and they will create a virtual machine for me, which has an IP address. So there are actually different type of IP addresses that will be provided by the cloud service provider in the if we are making a virtual machine. It will be a public IP, or there is a, so I'll write it public. So there will be public IP or there will be private IP. So either it will be public IP or there will be private IP, means both the IP will be provided to me. With the help of public IP, I can log in into that particular system, and the private IP is used for communicating with other virtual machine that I have created. So let's say this I have created virtual machine 1, and there is virtual machine 2. So private IP and the private IP of this is also used for communicating with these two. So that is an internal part of it. We'll not go into the detail of that. What I'm saying you is that whenever I require anything very easily, I can do it with the help of the cloud service provider. So that characteristic should be there in the cloud service provider. Means easy on demand, my machine should be created, easy on demand, my service should be ready, easy on demand, my resources could be scaled up or scaled down based on my requirement, and it will be a self-service type of thing. It means that the cloud service provider will not do interference of creating all those things. They will not do anything. They will just configure the cloud computing infrastructure in such a way, they will create the interface such a way so that I can actually use those the interfaces in a very easy basis, and I can create my own infrastructure. On demand, why it is on demand? Let's take an example of that. Let's say I have host my my website into a, let's say, Amazon Web Service. I have used the EC2 service of infrastructure as a service, and I have made my virtual machine, and I have put my website over there. And let's say there is a hit in my website, and slowly I find out that the load in my website has been increased drastically. So what cloud service provider will do is they will scale up. Let's say I have chosen 4 GB of RAM, 100 GB of hard drive, or 4 core of processing. They can increase up, or they can scale it up the resources whenever it is required. So based on the requirement or based on the necessary on demand, these services could be increased, as well as if the load or the traffic is very less in my system, so they will scale out all those resources that has additionally add up at that particular period of time. So that is called on demand self service. So that facility should be there in each and every cloud service provider. That is the first essential characteristics. So I think that is clear to all of you. The second characteristics of the cloud service provider is the broad network access. It means, the meaning is, because everything is attached with the network. If network is not with the high bandwidth, or the network has configured in such a way that the outside users cannot access it, or it doesn't allot the bandwidth accordingly, so it is of no use. It means, let's say I want to use my virtual machine that I have created just now, I can use it if I have the internet. So if I have the internet, I can easily go into the my virtual machine. I can easily open it. I can do my work. So what I want to say is, this particular broad network access facility should be there in cloud service provider. Means there will be no issue of bandwidth. So high bandwidth should be there in the cloud service provider. Means if I want to create my private cloud in my institute, so I have to look for the high bandwidth, so that all the students who want to use my cloud services, which is a private to my institute, definitely my institute people can use it very easily. So that is one big thing that is there with all the cloud service provider. Next thing will be resource pooling. So I told you about what do you mean by resource pooling, right? Let's see in detail. The resource pooling means, what are the resources we have? If I list the resources, what are the resources that cloud service provider will give you? They will give you the resources like RAM. They will give you the resources like storage. They will give you the resource like the CPU or the GPU, right? They will give you the resources of, let's say, and the bandwidth that is allocated to me. So all those are, let's say, there are many other resources, but let's say these are the resources that service provider has given me. So I have been allotted, let's say, 4 GB of RAM. I have been allotted, let's say, 20 GB of storage. Let's say I have allotted 2 core of CPU and 1 core of GPU, and I have allotted, let's say, 5 Mbps of bandwidth. Okay. Now let's talk about this. Let's talk about this RAM. This RAM is of 4 GB. Do you think that they have a 4 GB of RAM, and this RAM is allocated to you only? Let's say if it is allocated to me, let's say SS Suresh Sharma, it is allocated to me, and I am just using it. Do you think like that? No. Actually, there is a RAM of a bigger size, and that bigger size RAM will be used by me, that be used by, let's say, another people, that be used by, let's say, another people, that will be used by another people. So the big chunk of RAM will be used by different users. And this particular resource, one resource, will be pooled by many other users. The same thing will happen to the storage. Do you think that they have only 20 GB of hard disk available? No, they have, let's say, 1 TB, or let's say 100 terabyte of storage. This 100 terabyte is divided into n number of a user based on that their usage, and they are using only one hard drive to different people, and it will allocate the part of that. So that's why it is called virtual machine. It is not physical machine, right? It is a virtual machine that has been created and that has been given by cloud service provider. That's why all those resources could be pooled. Let's say if I required 4 core of memory, so what they will do, they will add up another core to my requirement by taking from other user. Or if if it is already there freely, they will allocate to me. Otherwise, they will allocate. Now, what about the bandwidth? If the network bandwidth is, let's say they have 100 Mbps, so what they will do is they will divide this bandwidth into number of users, like you do in your farm or you do in your college. Like you have the input of, let's say, 100 GB of 100 Mbps of bandwidth, and you are just using by this is used by different users. So this is an example of resource pooling. So that's why because of this, there is a concern of security. So we'll talk about it, and we'll discuss about the security perspective of the cloud computing also in some next section of this particular lecture. Now here, the next one is called rapid elasticity and expansion. Now, elasticity, what do you mean by elasticity? The meaning of elasticity is like your elastic, the shape can be changed based on its tension. So if we'll give the force to the elastic, the shape can be changed. Shape can be increased or can be decreased and come in the regular position. So it can be increased in some way, some extent. In the same way, in the cloud computing also, the elasticity is a very important characteristics of cloud computing. So if I require some sort of time, if I require more number of resources that is required by a user, that resources will be available to me at a particular time when I demand it. So the increase, scale up or scale down of the resources is a main characteristics of any cloud service provider, that the resource could be scaled up or resource could be scaled down based on the requirement of the user. So that's why it is called elasticity. The property is elasticity. Based on that, Amazon Web Services has made a product called EC2, that is called Elastic Computing Cloud. About that, we'll see in the hands-on when we learn the hands-on on cloud computing. At that particular time, we'll see this particular product made by Amazon Web Services. Is based on the elasticity, a property of it. Elastic Computing Cloud, EC2. Now come to the last one, which is very essential for the cloud service provider is called measured services. Measured services means the services given by the cloud services provider can be measured by them. Just like your electricity bill. So based on the usage of the bill, what we do is we'll pay the money. In the same way, so how it will be done? It will be done by the electricity meters that is there in my home. So that meter will tell the company that particular user has used these much amount of electricity, so you have to cost or you have to take that much of money. So just like your the electricity bill, or just like your telephone bill, or just like your data provider or data bill, right? The internet bill. So all these are the bills, right? What they do is they will measure the services, how much you have used. If you have used, let's say 100 GB in one month, so they will cost you accordingly. If you are using a telephone of, let's say 100 or 200 more call than the base price, so they will cost you. In the same way, the electricity, the water bill, right, how they will be generated? They will be generated based on the measurements. So how much they have given you the resource, and based on that they will cost you. So that particular part should be there with any uh, cloud computing infrastructure. This is also essential. Why it is essential? Based on that only, a cloud service provider will give you the bill, that much of resources you have used, so you have to pay that much of money, right? So that facility should be there, like they can measure how much resources they have been given to you at a for a period of time. So all these are the different essential characteristics of the cloud computing. So if any of the services or any of the characteristics are not there in the cloud computing, so it is not up to the standard of NIST. So to being up to the standard of NIST, these 5 essential characteristics should be there with any cloud service provider. Now let's talk about service model. So this particular service model you all have learned, right? You all have learned what do you mean by software as a service? What do you mean by platform as a service? What do you mean by infrastructure as a service, right? Now let's talk about these 3 services in detail. Now, the first service is called software as a service. So the first service is software as a service. Second service is platform as a service. Third service is infrastructure as a service. Let's talk about software as a service. Now, what do you mean by software as a service? So the cloud service provider will give their software, and it can be used by the user very easily, like any type of CRM software, email, virtual desktop software, communication, games. So online games are very much is the example of SaaS, software as a service, or email services are the example of it. So how we can use all those services? So we can use all those services using some client software. So what are the client software we have to use? Let's say I want to open an email. So what I have to use? I have to use web browser. I'll open the web browser. I'll write gmail.com and I'll use those email services. If I want to play some game, let's say the PUBG is banned right now, right? Or any other Counter Strike or other games. If I want to play, so how I'll play it? I have to have the mobile app or the application related to that particular game with me. I'll just log in into the game and I'll use the game. So actual game is not in my mobile. Actual game is there in the cloud, and I'll use that cloud only. So how I'll use it? I'll use some client software for that. So here in the case of games and all, I'll use a mobile application. Or let's say if I want to use the database like Oracle database. So I'll just go to the oracle.com. I'll just register myself and I'll use the Oracle for creating my tables, doing the queries, and also how can I do that? Either we have the thin client for that, or I'll use the browser, right? So software as a service is a very big service provided by different product based company which are creating the product. Instead of purchasing that product, we are just using it. Let's say, as I told you, Oracle or any other services uh, any other software that I want to use it, I use those softwares, and I don't have to take the licenses. I don't have to install the whole software in my system. Instead, what I'll do is I'll install some thin client software, and with the help of these thin client software, I can use it. Or I'll use just the web browser, or I can use those softwares. So here, what will happen is I don't have to worry about the upgradation of the software, right? I don't have to worry about purchasing the software again and again. Let's say if the software is outdated, I don't have to uh, purchase that, and I don't have to install the new software, or the security patches are coming. So I don't have to worry about it, right? If I'm using software as a service. Now, the many other thing that you are using right now is Google Drive, right? So the Google Drive is a software as a service or platform as a service. So the Google Drive is actually software as a service. They will give you the facility of storing your data, but they will provide you the software to use it. They will provide you a user interface to use it, like a Dropbox. So you might have used Dropbox also for storing your data, right? So that is the example of software as a service. So how you can use Google Drive? Either you'll use the thin client for that. Thin client means you just install the application either in the mobile or in your system, or you'll use the web browser to go to the Google Drive and use it, right? So all these things you can do it based on this software as a service. Okay. Now let's talk about the next one, which is called platform as a service. Now, what do you mean by platform? The meaning of the platform is, or the usage of the platform is, whenever I want to, let's say, I am the developer and I want to create a software, or I want to make an application. So what is my requirement? My requirement is I should have the whole system with me. I don't have to worry about the operating system. I don't have to worry about the networking. I don't have to worry about the firewall and all. But I should have the essential platform. Based on that, I can run my data, or I can execute, I can write my algorithms. So for that, I'll use a service which is called platform as a service. So there are many services which comes under platform as a service, which will give you the platform where you can have your data and you can have your program to write into the platform. So like executing runtime, so the execution software they will give you, or the database they will give you, you just put the data on there. Or web servers. Yeah, web server is another a good example of platform as a service, like godaddy.com, or there are many like hosting provider, right? So those hosting provider are nothing but hosting will giving you the platform where you can put your website and you can use it. Or there are the development tool. Developer are very much using all those tools. Like there is a uh, there is a platform as a service very popular nowadays is Kaggle. Kaggle, Kaggle, right? Kaggle or Kaggle. This is the product of Google, in which what we can do is we can do all the data sciences tasks, all the machine learning tasks, in which they will give you the GPUs, they will give you the essential requirement of running those data and all. You can have your data set, or you can download the data set anywhere you want. You just write the program for that, and to run that particular program, these Kaggle will give you high uh, uh, what high speed GPU, so that you can just run your program. You don't have to worry about the essential requirement. Let's say I have a laptop, I don't have the GPU on it, I want to do the data science project or machine learning project. So I'll use the platform as a service of Kaggle. So Kaggle is just like that. So it is a combination of software as a service and platform as a service. It will give you the platform in which you can run your software and get the results. So this is all about platform as a service, where you doesn't have to own the virtual machine. You have uh, the virtual machine and other essential software with you. You just have to use it, right? Now the last one and very essential service about the cloud computing is called infrastructure as a service. Now, what is that infrastructure as a service? Infrastructure as a service is just like a virtual machine. So you have a machine, you have a laptop, you have a desktop. You want another laptop or another desktop. How you'll do that? So you just go to Amazon Web Services, go to the EC2 platform to it, and you can just create your own virtual machine. And how you will use it? You can use it either SSL, or you can use it some sort of putty or something. The thin client will connect your virtual machine and you can use it. So infrastructure, in the infrastructure as a service, they will give you the hardware, right? But what you have to do, you have to use the operating system. You have to worry about what you want to install there, what essential software you require. You can install those essential software on it, and you can use that machine as your own machine, as a virtual machine. So they will give you the servers, means they will give you the processing power, they will give you the storage, they will provide the load balancer technique in which you can balance the load, and they will provide you the networking. And what you have a virtual machine with you. That particular virtual machine you can connect with either SSL or thin client like putty and all. They will give you the public IP by which you can connect it. They will give you the credential, username, password, that also you can use it, and you can use that particular system very easily. So infrastructure as a service means it will give you the hardware. You have to do you have to install the essential software or operating system, whatever you want. And you have to choose that how much hardware I required, right? So here, these are different services. So I think you understood all these different services. If you have any doubt, I'll take the question at very last. So you can take your question, or you can write it down into the chat, so that will accumulate and will answer the question. Now let's go into the deeper and try to understand all those services in detail. Let's say if I have a server on my premises, so what I have to do? I have to manage my application, I have to manage my data, I have to see what are the runtime platform I have to talk about or I have to configure the middleware, I have to install the operating system, all the virtualization software. The server I have to, means CPU I have to configure, I have to worry about my storage, and I have to configure my network. So if I have on-premises hardware with me, I have to do all those things. Let's talk about different cloud services. Now, the first services that we have just seen, will start with the infrastructure, as we have seen this infrastructure as a service very last. So what is infrastructure as a service? In which the cloud service provider will give you the hardware, an essential requirement of that. So what they will give you? They will give you the hardware, or they will give you the whole resources. So they will give you the virtualization's essential software, they will give you the CPU, they will give you the storage, and they will provide you the networking. So all these things will be done by the cloud service provider. What is your responsibility? Your responsibility to install the operating system, your responsibility to install the middleware, you have to the responsibility to install any compiler or any runtime software, you have to put the data, or you have to put different applications on it for running it. So actually it is a virtual machine that will be provided to you. So they will provide you the hardware, rest of the, they will provide you the hardware and essential software with networking. Okay, without networking, you cannot do anything, right? Without networking, how you can connect? So they will provide you hardware along with essential software and networking. You have to worry about, or you have to manage operating system, middleware, runtime, data, and application. Let's talk about platform as a service. In the platform as a service, along with the platform, they will give you the hardware. So the hardware and the platform, they will give you. What is your responsibility? Your responsibility is to install the application which you want and install your data. They will give you that. So they will give you the application, what application you want or what data you want to put there. Just like Kaggle. In the Kaggle, everything is there. What you have to do, you have to create your own algorithm, own data science algorithm. They will give you the platform, everything. They will give you the Jupyter notebook. They will give you different Python platform, pandas and all. They will give you. You just have to write the application and you have to have your own table or own data set. Then you can do all those machine learning thing, whatever you want. And everything will be managed by the cloud service provider. That is called platform as a service. Now come to the last one. Last one is called software as a service. In this, you don't have to manage anything. Like your emails, you don't have to manage it. You don't have to worry about networking. You don't have to worry about storage. You don't have to worry about how much CPU has been allocated. You don't have to worry about anything at all. You don't have to worry about operating system. What you have to do, you have to just use it. Like your online games, right? You just put your username and password and you will go into that, you will connect to the cloud and you can use the facility given by the cloud. Or the Google Drive, Gmail. There are many Google Suites are there, right? All the Google Suites are nothing but software as a service. The CRM software, so all those are different examples of software as a service. So I think you understood all those things one by one. So this is the different services provided by the cloud service providers. Let's see which service we have to choose depend upon our requirement. So let's say if we have to choose the software as a service, so who can choose software as a service? If you are the end customer who uses software like Microsoft Office, emails, social networks. So software as a service is a perfect for you as it is primarily suited for the end user. So if I want to use MS Office, I can use the online version of that. If I just say your Google Doc, right? Google Doc is an example of that. Email, social network, your Twitter, your LinkedIn, your Facebook, everything is the software as a service that you have to choose. Next is platform as a service. Who choose platform as a service? If you are if you are into development, who doesn't want to manage infrastructure? Let's say you don't want to purchase GPU by your own. You don't want to spend money on the GPU or the CPU. So what you use? You use the platform as a service. Is suitable as you want to focus on developing the application without bothering about the management of the platform. So if you doesn't want to manage the platform, you doesn't have to worry about the essential runtime requirement or runtime compilers. So you can use platform as a service for that. Okay. Or you want to deploy your website, then also the platform as a service is very much useful for that. You don't have to worry about the web servers, right? You don't have to worry about managing all those web servers, configuring it, looking for the securities and all. You just put your data and the application and use it. The platform as a service. The last one that is there, which is called infrastructure as a service. So who will choose infrastructure as a service? If you have a complicated IT implementation that you are migrating to the cloud, infrastructure service can be right solution for you, as it involves the developing of infra right from the scratch. Now that infrastructure as a service is for the firm, the company which have their IT infrastructure with them. Like we have seen in the first example, the on-premises. So if I am a firm and I want to use the cloud service, so which cloud service I'll use? I'll use infrastructure as a service. Like in Odisha government, as I have discussed in the last my class, that they have created infrastructure as a service here as a private cloud they have created, and they have made as a infrastructure as a service. So many e-government websites are there. Many e-government activities are taking place in that particular private cloud. And this particular private cloud is providing infrastructure as a service. Okay. So these are different requirement in which we can choose any of the services that we require from the cloud service provider. Let's see some of the examples related to that we have right now. So software as a service. So what are the examples we have? Salesforce.com, Microsoft Office 365, Box app, Google applications, Amazon Web Services, Concur, Zendesk, DocSign, Dropbox. I can add Google Google Suite, right? G Suite. All G Suite are the example of software as a service, which is already there. This one. Now come to the next one, which is called platform as a service. So we have Amazon Web Service, Elastic Beanstalk is an example of platform as a service, or you can say Kaggle, which is provided by Google, which is also a platform as a service. Salesforce, Software AG, Microsoft Azure is a platform as a service. IBM, Bluemix, Red Hat has also provided platform as a service. OpenShift is a product of that. Virtual Machine is another company which is providing Pivotal CF, and Google App Engine. So we have different app engine which is for the development of different apps, right? So if you want to develop the Android application, you can use the app engine for that. Or you want to create the website or anything else, you can use that Google App Engine. That are the example of platform as a service. Now let's talk about the last one, which is called infrastructure as a service. So we have example of that is DigitalOcean, IBM Cloud, Amazon Web Services, Microsoft Azure, OpenStack, Rackspace, VMware, Red Hat. All these are the company name, right? All these company provide us infrastructure as a service. If I want to create my infrastructure as a service, or I want to create my infrastructure, I talk to these cloud service provider and they will give us the right choice of our infrastructure to creating our infrastructure. So all these are the thing related to infrastructure as a service. So as we have discussed, there are different cloud service providers right now based on their popularity and based on their stack. So I think most of the stacks are with Amazon Web Service is a very big company. Then Microsoft Azure, Google Cloud Platform, IBM Cloud, Rackspace, all these are company names. GoDaddy, Version Cloud, VMware, Oracle Cloud, DigitalOcean, Red Hat, Mac Cloud, e-commerce. All these are different company names which are very popular in the field of cloud service provider. There are other company like Dell, EMC. So you know that there is a merger with EMC and Dell, and they are in the business of cloud computing, and they are creating actually a hybrid version of the cloud. So that we'll see just now. So I think you understood different services different services provided by the cloud service provider and different company which are actually giving you these type of services. Let's talk about the deployment model. So based on actually these model, we'll talk about security and privacy concern. So we have different deployment models. So we'll see one by one. First one is the public, private, then community cloud, and then hybrid cloud. Let's go to the first one, or we'll try to read out the essential of it, and then we'll go to in detail. What is a public cloud? So it says that the cloud infrastructure is provided for open use by the general public, right? For the general public as well as for the open use. It may be owned, managed, and operated by a business, academic, or government organization, or some combination of them. It exists in the premises of the cloud service provider. So whoever the cloud service provider is, that public cloud is there in the premises and it is public to all. So anybody can use it. And it will be provided by either owned by the company, or it will be managed or operated by a business company or any academic institution or government organization, right? Next is the private cloud. So what is a private cloud? The cloud infrastructure is provided for exclusive use of a single organization, comprises multiple customers, or sorry, multiple consumer. So there are private cloud. The concept of private cloud is the whole infrastructure is made for a particular company or a particular organization. So definitely in one company or in one organization, there are multiple consumers. So it may be owned, managed, and operated by the organization, the third party, or some combination of them. So here in Odisha, they have created the private cloud. Who have created? The third party who is managing. Hardware is with us, with the Odisha government, but that cloud is a private cloud they have made. An infrastructure as a service they have made, and it will be managed by the third party, which is called VMware, and it is organized by the Odisha government only. So this is a great example of private cloud. Then we have a community cloud. The concept of community cloud is, let's say if two or more organization, they are working in the same project. So what they do is they will tell the cloud service provider to make a community cloud, and this particular community cloud is actually public within some an organization which are working on the same project, right? And it is private to them. You can say it is public to them as well as it is private to them, but it is not public to the other people. Outside people cannot use it. Hybrid cloud. Now this hybrid cloud concept is what is this is a mix of private, community, or public cloud. This is a unique entity where the research is actually going on. What is the usage of that? The usage of this hybrid cloud is for the people or for the organization who want to make a balance between the cost and balance between their security. Let's say if there is a firm X, that firm X is using the private cloud, so the concern was the security of their data. If the same firm X want to use the private cloud, security is there, but there is the problem of high maintenance as well as more cost. So to manage these two, the company like Dell EMC and many other companies who are coming, and they are providing hybrid cloud. This particular hybrid cloud is the combination of private and public, where sensitive data will be filtered and put into the private cloud, and non-sensitive data will be filtered out and put into the public cloud. So it is a combination of this. Let's say the 60% they are using public and 20% 40% they are using private. So they doesn't have to pay 100% for the private, right? So cost effective and load balancing can be very easily done in the hybrid cloud. Let's see with the help of the diagram. So this is a diagram for that. Here it is a public cloud. There is a cloud. This particular cloud could be used by different users. So these users are using that terminate the access. These other user can use it. Here what will happen is there are new hardware that can be used, as well as there are old hardware that can be used by all those users, and these resources could be used by anybody. So there is no restriction at all. Anybody in the world can use this. So actually what will happen is the users are outside. Next is the private cloud. So what will happen in the private cloud? The users are actually inside the user only. No outside user are allowed. So that are blocked. Outside user are blocked with the access in the private cloud. Now what happened in the community cloud? There is the cloud that they have made. The inside people can use it, as well as there are different organizations which we consider as an inside. They can also use this particular community cloud. So it is just like if let's say there are 10 institution, and all those 10 institution want to work together. They are actually working in the same project and same sort of similar type of program. So they can make this particular community cloud in which they can use the cloud and they can share the cost among themselves. So here privacy also can be maintained among the organization, and outside people other than these organizations cannot access it. This is the example of community cloud. Then we have another cloud which is called hybrid cloud. So as I told you, in the hybrid cloud is a combination of public and the private. So either these private cloud is inside the premises, or it may be outside the premises, but it is private. So the whole hardware, so there is no pooling of resources are there. So pooling of resources means pooling of resources are there, but outside people are not using that particular hardware. So if we have a hardware and this particular hardware is only accessed by the organization, this is private. And there is a public one. So this public infrastructure could be used by outsider also, as well as would be used by this particular organization who is actually using these two. So as I told you, the sensitive information will go into the private and non-sensitive information will go into the public, so that the cost will be maintained. Now for the today's topic, why it is essential. Why the cloud is essential? The question is why the cloud is essential. So let's search the answer for that. Okay. First of all, the cloud is a huge interconnected network of powerful servers that perform services for business and for people, that we know about the cloud. Generally, something that happen in the cloud is an activity that take place over an internet connection instead of on device itself. That is also a characteristic, right? Something is happening into the cloud means it is happening into the cloud. It is not happening into my local device. For much of the IoT, the head, or rather the brain of the system, is in the cloud. It means that the data processing, as I told you, the data processing, the storage of data, where we do. So we do in the head, right? So if the body is you consider it as an infrastructure of IoT in the body, your brain is working as a cloud, right? Means your brain can do two things. Your brain can store the data as well as can process the data and make the decision. In the same way, in the IoT infrastructure, cloud will store the data, process the data, and make the decision. These sensors and the devices which collects the data and perform actions, right? So we have different sensors and devices which will collect those data and perform the action. So in our body, what are those? In our body, we have tongue which will test. We have ear who can hear. We have eye which can see. We can know. We have nose which can smell. So we have different senses, right? We can touch, we can feel, we can find out and these all these senses are generating the data, right? So let's say I am putting my hand into some warm place. So definitely after some time, if I cannot bear the heat, so that particular sense will go into my brain to take off my hand from that particular place, right? That happen. How that happen? The data will go the data will be generated by my sensors, let's say my palm. The data will go into my brain. My brain will process the data. If the heat is beyond my um, tolerance, so what brain will give the signal? The brain will give the signal to the actuator, which is your hand. So what are the actuators we have in which we can take the actions? We have other movable parts in our body which is useful for movement. We have leg, we have hand, we have other movement that we can do in our body. Those are the example of actuators. And sensors are there, right? So we have many senses by which we can take the decision, and this brain is just like a cloud where we can store the data and we can process all those data. So it says that the processing and commanding analytics, also known as the smart stuff, smart thing, is typically done in cloud. So can we say that cloud is important and cloud is very much important for IoT? By actually seeing that particular sentence, what do you think? It says that is a head, is just like a head, is just like a brain, it is doing the smart thing. So can we say that cloud is essential, or cloud, without cloud, the IoT is not at all possible? It says that technically the answer is no. No means without the cloud also IoT infrastructure is possible. Now for that, what we have to do? The data processing. So data processing we cannot ignore, right? Data processing we have to do. Commanding we have to do, means the result. So the data processing, storage, commanding, all those things will be taken place locally rather than the cloud. Can we do that? Can we doesn't have to send the data to the cloud. Instead, can I use some sort of technique in which I can process locally? I can generate the result locally. I can store the data locally. Yes, it is possible. How it is possible? It is possible with the help of the concept of fog computing. So fog computing is a phenomena where all the most of the essential requirement of the cloud will be done locally. As well as we have the concept of edge computing. Edge computing means the last device, means just like your gateway node. So this gateway node, yesterday in the last class we have seen about the gateway node. So the gateway node will act as an edge computing device where it is collecting all the data. Instead of sending into the cloud, it will process itself. This actually make a lot of sense for some IoT application. Yes, for some IoT application, yes, it is possible. For some IoT application, yes, it is possible. But if we'll say that there are substantial benefit to be had using the cloud for many IoT application. What are the benefit a cloud will give you? Choosing not to use cloud will significantly slow the industry due to the increased cost. So what are we doing? We are storing the data locally. We need the hardware for that. We are doing processing of those data locally. I need the resources. So the cost is increasing actually. If I'm using all those things that can be done by the cloud, if I want to make it happen inside the premises, cost will be increasing. Definitely, without the cloud, we can make the IoT infrastructure. But is it a significant? For a small project or for a small application, it is okay. But the application like automated car, applications like a robot, or application like a space aircraft, it is not at all possible. So what we have to do, we have to use cloud infrastructure for that. So importantly, cost and scalability are not the only factor. This brings us to more difficult question. What are those? So the cost and scalability is one thing, one aspect. There are many other aspects because of why we need cloud. So far, only been discussed the benefit of using cloud for IoT. Let's briefly summarize them. So what are the things that we have learned? Cloud can decrease the cost both upfront and infrastructure. Second, pay as you need for storage and computing. Third, high system scalability are available. So scalability and the availability are the main factor, right? It is available 24/7. It can be scalable very easily. Which one? Cloud. Increase lifespan of battery powered sensor or devices, right? So if there is a battery power sensors or devices, and if you are making it to store the data, process the data locally, so do you think that these battery will be last for longer period of time? No. So it will be better if you send these data to the cloud. Ability to aggregate large amount of data, it is not at all good thing. If we have a large amount of data, if we talk about big data, IoT is a great source of generating big data. So could we handle big data locally? Yeah, it is very difficult. Anything with an internet connection can become smart. So we know that if we are putting the internet connection, let's say if we'll talk about a smart AC, right? You have seen many advertisement related to that. If we'll make that particular AC and I have purchased the AC. Now I want to purchase the edge computing device also to process it. Is it a smart thing? No. Instead, I'll use the cloud of that particular AC company, and with the internet, I can make that particular application possible. So with the help of internet, everything is becoming smart, like your Alexa and all, right? It will take my command, it will do whatever I am telling it to do. Do you think that all the processing power is there in a small device like Alexa? No, it is not. So the cloud is helping to do that. So what is the conclusion? The conclusion is cloud is not essential to IoT, but it is important to IoT. Okay, it is not an essential characteristics that cloud should be attached with means IoT should be attached with cloud. No, but yes, for different applications, if we are using the cloud, it is making our application possible, right? So that's it for today's class. I hope you got some idea behind cloud computing. You got some idea behind different services, different characteristics of the cloud, and you know that right now in that particular position, you know that IoT is important to IoT, and it is essential for the success of IoT. But yes, it is not important thing like to IoT. To if you are making the IoT infrastructure without cloud, it is possible. But to make it a successful or to make it a good way of doing that, let's say if you take the example of Mobus, you assume that I am not using any cloud, then what will happen? So is Mobus is possible? No. Mobus application is not at all possible if we are doing everything locally. So for the successfulness of the IoT application, cloud is necessary. So that's it for today's class. So I think if you have a question,